Okay, so let's work on a couple of future value problems. And what we're going to be doing is working on the future value of a single sum. We're not going to get to annuities yet. We're just going to look at a single sum. So for the future value, we know what something is worth right now. We want to know what it's going to be in the future. Remember, for the present value, we know what it's going to be in the future, but we want to know what it's going to be right now. But here in future value, it's our unknown is the future value. So here again, here is the formula for the future value, assuming compound interest. If we have simple interest, it does not matter, because remember, simple interest, we're simply going to take our principal amount and multiply it by the interest rate every year, and that's how much, and then we'll add that on top. We don't need to go through any fancy calculations, but because this is compound interest, we need to do this. So this is, again, if you like formulas, this is right up your alley. So the future value is the present value times the future value factor. Now, the future value factor is what we're trying to find, right? We're using those tables at the back in order to find that information out. All right, so let's take a look at an example here. We've got Bruger Company. They want to determine the future value of $50,000 invested for 5 years, compounded annually at an interest rate of 6%. How do they figure that out? Now, using the formula, this is what they do. So they take the 50,000. Remember that earlier formula that we used, in order to find the future value factor, we take 1 plus the interest rate, the compounded interest rate, times the number of times that it's compounded. So here they're compounding it annually at an interest rate of 6%. So here the future value factor in this problem is 1.33. Now I'm going to pull up the table so that you can see how this works. And I think they said 6%. Yes. Okay. So if we have 5 years, factor of 5, and 6% is our interest rate, and it's done annually, here is our future value factor, 1.33823. Everybody can see that? Here's what they get. They did the math on it. We get the same number on using our tables, using the tables. If you can use the table, though, it's easier. Although if you're good at math, it might be easier to use the formula. But there's our future value factor. And then what we do is we multiply our principal, that 50,000, times the future value factor. And that gets us $66,912. So they invest $50,000 right now, and they're investing it for 5 years at compound interest. Interest rate is 6% a year. It's compounded annually. At the end of those 5 years, they will have $66,912. All right. So we already saw what table that we use. We use that future value of a single sum table. That is the same table that I just showed to you, that I just pulled up here. Let me show you again. Future value of 1. Future value of a single sum. So they're showing you exactly what I just showed you, where they found this information, which is right here, 1.33. So there you go. Same thing. So this is just showing you exactly how that works. Exactly the same way it works with those tables. Okay, so let's do the same thing, but let's add a little complication to it. Now we've got Commonwealth Edison. They deposited $250 million into an escrow account with Northern Trust Company. They did this at the beginning of 2017 as a commitment toward a power plant to be completed December 31st, 2020. So they're going to build something. They're going to need this money in 4 years. And so they're putting the money aside into an escrow account. How much will the company have on deposit at the end of 4 years if the interest is 10% compounded semi-annually? All right, so let's take a look at this. Let's use our table here. All right, so we have, here are our factors. So we've got 250 million. Right? And so they're going to need it in 4 years. And it's compounded semi-annually. And it is at 10%. All right, so let's find our future value factor here. So because it's semi-annual, remember, what we're going to want to do is we're going to take our interest rate, divide it by 2. So now that's 5%. Right? And then we're going to take our periods, number of periods here, 4. We're going to multiply that by 2. Now we've got 8. So now we're going to have to look at the table and use 8 periods at 5% to find our factor. So we find 8 periods here at 5% here gives us a factor of, where do we go here? 8. So it's 1.477. 5%, 8 periods, 1.47746. So there's the factor. Let's go back to our problem here. So which table do we use? Well, we're going to use the future value of a single sum table. So there's our 250 million. There's our factor that we came up with as well. So the future value is $369,395,000. So if we look back at our factor, we had the factor, right? 1.47746. We just multiply the 250 million by that factor, which the authors did for us, to get $369,395,000. That's the future value. That's how much it's going to be worth in 4 years at 10% annual interest. Okay, so that is how the future value of a single sum works. We're going to move on to the present value of a single sum, where we're going to use the present value table.